We started out first focusing on creating common assessments, making sure that they were standards-based. And believe it or not, that's a process. I mean, that isn't something that just, oh, everyone is doing that. You might be surprised if you sit down with a test and go back and look, what objective does that really master? Is that test question mastering trying to get at 2 or 3 objectives, and then we're not sure what the student doesn't understand? All right, we're going to begin today's team meeting looking at our Unit 5 test results, which we gave our common assessment on about 2 weeks ago. And so if you could open up your spreadsheet to Unit 5, and we'll start going through each question, trying to identify the topics that we're going to include as review questions on our Unit 6 test, which is coming up next week. So we'll start off with question 1, and the concept here, total electrons, valence electrons. How'd we do? So our first task was to develop common assessments, and that probably took us maybe a year and a half, 2 years to really develop what we felt comfortable with common assessments. And then as we developed the common assessments, it then led us through to, okay, well, now that we have this data, this should be able to make our tests better. So that was our first strategy. Okay, let's make sure the test questions are testing what we want them to test, mastering a particular objective only, and really isolating it, and then revising questions that didn't do that either our students weren't successful on across the board, or the distractor provided us with some information as to where the misconception was. Linda, my data matched yours. My students did better on question 9 with that drawing as compared to question 13. I still had majority get 13 right, but not to the same extent.
Yeah, mine were really varied. I can't understand why. I mean, because I would think the distractor mine chose, was B. So they had the right number of valence electrons. They got their spin. They weren't in the same spin. So it's that little fine detail on Hund's rule where they spin the same direction.
There's a big difference between 9 and this one, in that there's an S and P. And this particular one, it refers only to the P.
Good point.
And that is probably why my kids did better the second time out, because they were able to focus on the P sublevel. And that made all the difference with the 3 orbitals. So there's going to be 1 in each.
Matt, what are you?
I think I just spent more time going over the rules and how to apply the rules, making sure that everything looks the right way, versus taking those rules and applying to identifying the element back in the periodic table.
I will say that I don't think I spent any time talking to them about up versus down when they're there alone.
Right.
So I don't think, for me, my students would have had any knowledge to choose C over B. Do you see what I mean? They're
But
the
yet
same.
Your kids did.
But they did. I don't know why, because I didn't spend any time. I spent the most time making sure they knew that those 2 electrons would be separate, not that they would both be spinning the same
I was
direction.
gonna say, I think that's a real fine line. If I combine those 2 answers, my kids did very, very well.
Me too.
So they knew how things were spread out, but couldn't make that real fine detail choice in between the 2.
And then from there, the next progression was, okay, now we have tests that we feel pretty comfortable with. We still edit them. They are fluid because it depends on the instructional achievements we make. We then have to revamp and say, well, now they have this, but let's work more on that. Now we're really to the point where we're evaluating instructional methods, which is, okay, how did you teach the concept of stoichiometry? Did you use ratios? Did you use factor label? Did you use unit conversion? So we're really getting into those types of conversations. But again, it's been a long progression to that point. That isn't something that just happened instantly.
Do we all do dimensional analysis the same way? I know that you use it
Factor
where
label.
you set up multiple things,
Steps.
multiple steps within
Right.
one problem,
problem.
where I have my
Factor
students do
label.
3 independent problems for a 3-step equation.
Oh,
No,
so
I do
that
a lot of one. That was
That is probably why you're having more success at it than I am in particular.
Yeah, because they
Because
understand
mine is
one-step problems.
one-step problems,
So I just
right.
take that one-step problem and make them do one step, and one step, as opposed to bridging it all together.
Yeah. And my problems are bridged all together.
Mine too. Do
Mine
you think
too.
that would help with special ed if they did? Or do you already do that?
No, I do the one big problem, but I will try that. That sounds right.
That's fascinating. I think it'd be really interesting.
Yeah, I'm gonna try that, Matthew.
Okay.
Because what I'm doing isn't working. It just isn't working. One big problem where I have everything set up and you just follow the steps through.
Well, maybe then we could do a compromise, since we could do that for a
One-step
one-step problem.
Exactly.
No
Right.
Because
calculator answer.
then that matches what you're doing.
Yeah.
Right.
Definitely, and that can also not even be a review question. That can be used on a mole, because a mole conversion is already one step.
Yeah. That is it. The problem is when you're doing mass, then you've got some headaches. That's the difficulty.
How do your students feel, Matt, when they're doing mass, and you're saying, okay, there's three
three
steps?
separate
Do they have a
steps.
hard time? You think that,
They feel comfortable knowing that they're doing the same level of difficulty problem, but it's just longer.
okay.
They understand that it's not any more challenging, it's no more difficult. There's just 3 independent steps that they have to do.
Hold on, Matthew. We discussed this about doing the mathematical proportion. How'd that work out? For
I
the
didn't-
same mass problem.
I didn't do it.
You didn't do it.
No.
Because there's a built-in error there, isn't it?
Well,
With the moles.
because my students are so weak in the math, I decided that it would probably be better not to show them the proportions.
Right.
So then they wouldn't have to think, when can I use a proportion and when can I not? Because I didn't want them using proportions if they're solving for molecules or volume. So if I have a student that's having a my stronger math students, I'll show them the proportions on the side. But for my weaker math students, I keep them with the same level of math every single time, so it doesn't get any more challenging for them. They don't have to remember the exceptions.
That's a lesson I need to learn then.
But I do think we need to remember that based on our results last year of our state assessment, our stoichiometry scores, our standard 4 scores, went up significantly over last year. And I think that's probably now being able to be attributed to 2 things. The first being the spiraling, where they're doing a little bit of stoichiometry, a little bit of unit conversion all the way through, and that catches most of the students. And then on top of that, possibly doing the 3-step that Matt's approach, doing 1 conversion for each problem. So we'll need to continue to fine-tune that, but I think we've made a lot of strides in Standard 4. I know you're still a little frustrated, Eugene,
Yeah.
but I think we've definitely made strides based on our data that that our Standard 4 scores have gone up.
Well, one tricky one that often comes up is asking and answering questions, like asking students to come up with questions that might be answered in the text. And that's something too that often shows up on the state assessment as well, but also it's just a bigger idea, a critical thinking for reading, and it goes across content areas, like with science, like with the cycles that we're talking about, like the Earth cycles. I think just asking them to generate questions that might be answered in that text and using maybe leveled texts that we can get from the book room about that one topic, and then having them maybe create questions that the text might answer, and then going back and like doing that research. I need to focus more on nonfiction, I think, for my kids, because that's one too where meaning is falling apart at times and it's affecting content,
I think
and their understanding.
in order to work on that point, come up with question is having them do like role play. They are the teacher, and so teachers ask questions. So what kind of question can you come up with? I think that would be like a play at the same time, but they're gonna have to come up with questions.
And the importance of students understanding how to ask questions and how they're related to the text, which is that question-answer relationship concept, that if they understand where the questions
So they
come
will know.
from, they can understand how they're going to find the answer. So just to kind of add on to what you said, teaching them the questions, and if they're formulating the questions, then they should be looking at where am I going to find the answer for these questions, or maybe it's not all right there in the book, but it's really moving into that idea all across the content and language arts.
For the nonfiction books, what you can also do is, what I've been trying to do with the kids is having them create their own questions, kind of like the nonfiction books, but in social studies or in math or in science. You know, you're going to become the teacher and you have to ask the class 3 questions. What are the most important questions that you want them to understand? You know, you're going to become that book. How do they find the information? How do you ask them, you know, just getting them into the habit of asking questions and preparing questions and stuff.
You said something really key though about most important questions, and that's another strategy that we can be teaching across the curriculum with the fact that they have to determine the importance. What is important? So as you're thinking about how are they going to do that task, what are you going to need to be teaching them to do it? So another way to
Right. And going back to the
An effective leader plans these strength-sharing opportunities because she understands the value they bring to the process and the outcome. There was a lot of candid conversation going on in those meetings, wasn't there? What will you take back to your school so that you can begin to build capacity and utilize the built-in professional development that's at your fingertips? We're almost finished with this module, but there is one additional indicator that we don't want to overlook. This course has focused on leadership and the kind of leadership that is needed to achieve and sustain teaching and learning in the classroom. Providing purposeful and data-informed professional development opportunities for staff is an important aspect of leadership. And while we didn't spend much time focusing on formal teacher evaluation in this segment, we'd be remiss not to mention that the indicators used to inform professional development needs, the indicators of effective teaching and classroom management, should be the same indicators used in teacher evaluation. Teacher evaluation examines the same indicators used in professional development. Remember, part of strong leadership is maintaining open and consistent lines of communication, getting everyone on the same page. Making the effort to get everyone there and then keeping them there allows you to focus more time doing the work and less time defending it. This concludes our course on leadership. Thank you for participating in the Indicators in Action. If you haven't already, please visit our other courses on instruction and school community. As always, we are eager to receive your feedback and questions related to the usefulness and usability of Indicators in Action. Thank you.